Hello everyone and welcome back to another session in IBDP MAI HL course, and this session is for paper 3 where we will discuss a question on topic 4 and topic 5 based question. Okay, so it's a 23 marks question as you can see over here. Okay, it says the curve y is equals to f of x is shown in the graph below, but this equation is not given. Okay, it starts from 0 to 4.4. Now, the y is equal to fx curve passes through the following points. We are also given the x and corresponding y values for these marked points. There are these 5 marked points on this curve. So we have x and corresponding y values over here. In the first part, it says it is required to find the area bounded by the curve x-axis, y-axis, and the line x equals to 4.4. So we are using various models over here. First, it starts with the trapezoidal rule. Okay, so we have to use the trapezoidal rule, and the formula of the trapezoidal rule is also in your formula booklet that you can use. We have to actually make some trapezoids over here like this. And we know the area of the trapezoid is given by half times sum of two parallel sides times distance between them. Okay. By the way, you can use the direct formula for the trapezoidal rule from your booklet, which says it is given by delta x by 2, what is delta x? Change in x values. Delta x divided by 2, and you have to take like different trapeziums. You will get total 4 trapeziums like this by connecting these points and drawing that perpendicular. Okay. So delta x, what is that? Change in values of x. As you can see, x value starts from 0, 1.1, 2.2, 3.3, 4.4. So delta x is a change in values of x, which is 1.1 over here. Delta x divided by 2 times. Now we have to write the first value and the last value from the curve. And twice the all middle values, means y1 plus y2 plus so on up to yn minus 1 point. Okay. So here we have y naught as this 2 value, and this value is yn. Basically, it is our fifth point. Okay, so it is y4. Now, delta x 1.1 divided by 2 times first value 2 plus 148 plus twice the middle values, means 5 plus 15 plus 47. Use your calculator to get this value, and it comes out as 156.2. So we got the area as 156.2 squared units using the trapezoidal rule. It is not the actual area. We don't have the equation of the curve, so we cannot find its true value, but we got its estimated value using the trapezoidal rule. Now, part 2 of the equation says, with reference to the shape of the graph, explain your answer to the part A1 is overestimated or the underestimated. Shape means what? Actually, when you have concavity upward, if it is concave upward, then the area comes out as overestimated. And if the shape is concave down, then the area comes out as underestimated. Means the area that we calculated from here is more than the actual value, then it is overestimated. If the area that we are getting using trapezoidal rule is less than the actual value, then it is underestimated. So in this question we have concavity upward. So our area will be overestimated, as you can see over here. This is going to be our answer, and I can show you. See, this portion is overestimated portion here, right? That's why overestimation is there. Next part. Now, for these following points, it says use all the coordinates in the table to find the equation of the least square cubic regression curve. So there are various regression curves in our GDC. Okay. This time they want us to find the cubic regression only. So we will calculate cubic regression using these points. So what you have to do is you have to enter these x and y values in the spreadsheet. Okay. Also, it says write down the coefficient of determination. That also can be calculated in the same way. First, let's calculate the regression equation. Automatically, it will give me the coefficient of determination also in the same column. So, In your GDC, select this new spreadsheet over here. Okay. Then enter all the x values in the column 1 over here, like the 0, 1.1, 2.2, and so on. And enter all the y values in this second column over here, which is 2, 5, 15, and so on. Okay. Enter these values first. Means you have entered the coordinates of the points. Now we have to find the equation of cubic regression, right? So for that, go to menu, okay, then statistics, then select the stat calculation, and in that stat calculation there are various regressions like quadratic, cubic, quartic, power regression, exponential, logarithmic, sinusoidal. So that depends on the question in which form they want us to give the answer. So we have to select cubic regression this time. So select cubic regression. Once you select cubic regression, it asks for the x list and y list. You already know that we entered all those x values in the A column and y values in the B column. So enter A column and B column like this. Next, hit enter and you will get the cubic regression. The cubic regression is ax cubed plus bx squared plus cx plus d, where the values of these coefficient a, b, c, d are given in this column. Okay, so in this way we can find the cubic regression equation. So what is the cubic regression equation over here? It is this a, I'll write here, it is going to be 3 point. Also we have to write our answer correct up to 3 significant figures. So I will get 3.88 x cubed minus 12.8 x squared plus 14.1 x plus 1.54. This is going to be the cubic regression. Okay, means it is just estimated equation, cubic equation, right? So next part is write down the coefficient of determination. Go down, okay, after this d value there is one more row which gives you r squared, and this r squared is the coefficient of determination. So what is that r squared? It is 0.999 something, so around 1. Okay, or also you can write for three significant figures 0.999 is also correct. Okay, this is going to be the coefficient of determination value. Now we have the cubic regression. Okay, the equation looks like this: 3.88 x cubed minus 12.8 x squared plus 14.1 x plus 1.54. In the next part, it says, write down an expression for the area enclosed by the cubic function, x-axis, y-axis, and the line x equals to 4.1. The meaning is, this time we have an estimated equation of the curve. Now we can use our integral. Okay, so we have to write the integration of what? This equation, cubic equation, 3.88 x cubed minus 12.8 x squared plus 14.1 x plus 1.54 dx. Now we have to take the limits also, limits of x. As you can see, x value starts from here, means from 0 up to this point where x is 4.4. So take the limits from 0 to 4.4. That is expression. That is the answer for this part. We don't have to calculate it for this C1 part. Yes, for C part 2 it says find the value of this area. So now you can enter this in your GDC. Okay. They go to calculate. Then in the calculator mode, select calculus and numerical integral. Once you select the numerical integral, it's pop up with a window like this. Here you can enter the upper limit, lower limit. Here you have to enter lower limit. Here you have to use the upper limit. Here you have to use the cubic regression this time, that cubic equation, and here you can write dx. Okay, so once you do this, you will get your answer directly in the next step. What is that? When you enter this equation like this, it gives you answer 143.378. As you can see, last time, right, using that trapezoidal rule, we got our answer as 156. So another approximation is 143.378 using this cubic regression. Okay, next part. It says a second possible model for y is equals to f of x is an exponential model. First, we calculated the area using the trapezoidal rule. Then one regression model, cubic model. This time we have to find an exponential model actually. Okay. So let's go for this one. And if you want to book a free demo or want to have regular sessions or tutoring sessions, you can contact me on this number either by WhatsApp or Telegram. Okay. Feel free to connect with me if you have any kind of doubt or want to ask any other thing. So it says second possible model is y is equals to p times e raised to the qx. That's our exponential form. I'll show you the definition also. By the way, definition is again given in your formula booklet. I'll write here log a base b equals c. This is logarithmic form for the exponential form. The same thing can be also represented as a equals b raised to the power c. The right side is exponential and this left side part is a logarithmic form for the same expression. After that, see, if you have ln of x, let's say, ln x means the it is log or natural log basically having the base e. Okay, if you are using the Casio calculator, then you have to enter e separately. Okay, but for TI and Spire and all, there is a direct option for natural log. So now log of x, if this gives you like this, it means it is common log and its base is 10. Properties of logarithm also. Let me tell you some properties. Log of a times b is what? Log of a plus log of b, whatever be the base is given to you. If you have log of a divided by b, that is log of a minus log b. Okay. Now let's get back to the question. Y is equals to p e raised to the power qx is the exponential model already given to us. Now it says using the same thing, show that ln y is equals to qx plus ln p. It means we have to convert this in this form. So I will use the definition here. This is the definition as I said. Okay. So we have y is equals to p e to the power qx. So let's rewrite it as y by p equals e raised to the qx. Now using the definition I can say natural log of y by p equals qx. Here I am just using the definition only. After that, I will use this property of the logarithm that says log a by b is equals to log a minus log b. That gives me natural log of y minus natural log of p equals qx. Now rearrange the term, take this natural log of p to the right side. That gives me natural log of y equals qx plus natural log of p. And hence the proof, right? That we have to show. Hence the proof. Now, after this, next part says explain how a straight line graph could be drawn using the coordinates in the table. Means for this above D1 part, we have to show that there is a equation, linear equation corresponding to this. Okay. For that, I'll use the GDC. Okay. So in your GDC, go to spreadsheet, right, again, and let's say in the column C, in the column A, we already entered X values over here. Here we entered already the Y values. Now in the column C, let's enter the natural log Y values. For that, go to this cell and write the formula equals what? Natural log of this. What is that? It is B1 actually. So natural log of B1. Once you enter this, hit enter, you will get automatically the value of natural log of 2 over here. Okay, enter it like this, equals natural log of b1 gives me 0.693147. Now you can drag this from here, drag this to the whole column. That gives me the next line. That gives me this. Now, I have the natural log of y values. Okay, so let's write x over here, y over here, and natural log of y for this one. Let's give the names to these columns. Okay, so then we come across like this. Now, we have to show that it's a straight line. Okay, straight line graph corresponding to what? natural log y and x corresponding to this, not corresponding to this. Okay, for this we already have an estimation. The graph is already given to us in the question. So natural log of y will be our new variable. Okay, so in your GDC, press Control and then this plus page button, which is just above to menu. Okay, and select this option, add data and statistics. Once you enter this, it shows you the following point that we entered last time in that C column, like this. Okay, now here click on this add variable part, click here and enter X. Okay, we have to select X. So I will select X from here. Now for along Y part, I will select natural log of Y part. Okay, this time natural log of Y gives me the graph of this expression. This is the graph for that expression. Ln y in terms of ln y is equal to qx plus natural log of p. And as you can see, it is a straight line from the graph. Okay, from the graph, as you can see, it's a straight line. So that shows that it's a straight line graph using the coordinates of the table. Now, by finding the equation of the suitable regression line, show that p value is this and q value is that. So what is equation? We have natural log of y is equals to qx plus natural log of p. We can also find the equation of linear regression from the same part. Just go to menu and then analyze, then regression and select show linear regression mx plus b. That will give you the equation of linear regression. So this is y equals to 0.98625x plus 0.60183. Actually, it is corresponding to this natural log of, it is corresponding to that natural log of y equals 0.9, sorry, not 0.9, I'll write it as qx plus natural log of p. So this is q. What is that? In this case, it is 0.986, correct up to three significant figures. And natural log of p, what is that? Natural log of p is 0.6. Natural log of p, I will write here. Natural log of p is 0.601831. You can also use your n solver to give you the value of p. Okay, either use n solver or use the definition of the logarithm. E raised to the power this 0. P is what? E raised to the power 0.601831. Either use this definition of logarithm or use the uh, n solver. So you will get the value of p as 1.83 from here, and hence the solution 1.83 as p and q as 0.986. Okay, that's the solution for D part 3. Now D part 4. Hence find the area enclosed by this exponential function x-axis, y-axis and the same line. Means we have to again find the area using that integral, but this time using this exponential model, right? So we have our exponential model looking like this. Y equals p, which is 1.83 times e raised to the power qx. Q is 0.986x. That's our cubic model now. So we have to integrate it with the same limits from 0 to 4.4. In our GDC, we can do that. Okay. So once you do this 0 to 4.4 and enter the same equation over here, this time you will get your answer as 140.284, which is another approximation using this exponential model. Okay. So that is the answer for this part. So that's it for this session. I hope you got all these. If you still have any kind of doubt or anything to ask, feel free to connect with me using this number. Or if you want to have online sessions, one-to-one tutoring, or need any other information, please feel free to connect with me on this number. Thank you for watching this. See you in the next part. Keep watching, keep learning.